we've had a look at some practical examples of 3 different functions that you could find in section 3.1 of the lecture notes. So what we now need is to formalize things mathematically. To make it simpler, let's think of a specific example for a function f of x. So this is just a general curve. And we talk about the limit in terms of being the value that f of x tends to when x approaches some point. Let's say this point is a. And let's say that f of x approaches point with a value b. Now, it is important to understand that the limit in this case is b and exists because if you approach it from the left or from the right, you get to point b. Mathematically, a limit is written with an operator that looks like this. And if we're calculating the limit of f of x when x tends to a, essentially this process of seeing which value it converges, we write x tends to a of f of x. In this case, I will use these brackets just to mean that this is an operator, something you're operating f of x so that it returns something to you. In practice, this limit only exists if and only if you get the same value if you go from the left or the right. Mathematically, you'd write this as the limit when x goes to a from smaller values, that's a minus, of f of x, equals the limit when x goes to a from plus values of f of x. So for functions of just one variable, whenever we say the limit exists, this is what we mean. It converges to a value that in this case would be b, and it converges to this value from the left and the right. If it converges to one value from the left and another one from the right, then we cannot write this. It means the limit is not defined. These individual kind of limits from the left and the right can still be calculated, but the limit does not exist. The question is, how do we calculate limits and why are they useful?